Hello everyone, welcome to the class of Artificial Intelligence and Machine Learning. I am Ram Nivas from Department of Electronics and Communication Engineering. In today's class, we'll see about machine learning and its applications and future trends. Machine learning is a subset of artificial intelligence that enables systems to learn from data without explicit programming. ML algorithms improve their performance automatically by learning patterns from historical data. The main goal of ML is to make predictions or decisions based on data. We know that we have three types of learning, like supervised learning, unsupervised learning, and reinforcement learning. The supervised learning uses labeled data to train models, and it can perform classification and regression. Unsupervised learning works with unlabeled data to find hidden patterns. For example, we can say an clustering operation. Reinforcement learning learns through interaction with an environment using rewards and penalty. A good solution will lead to reward and a hindrance will lead to penalty. ML is widely used in healthcare for disease prediction and medical image analysis. In finance, machine learning is useful in detecting frauds, credit scoring, as well as risk analysis. ML powers natural language processing and computer vision applications like chatbots and image recognition. ML has advantages like automation and accuracy, but also limitations such as data dependency, bias, and high computation cost. This is a mind map representing machine learning applications and future trends, and we'll get introduced to machine learning and we'll learn about the importance of machine learning in real world applications. And the real world applications are healthcare, finances, autonomous vehicles, and recommendation systems. And in an overview, we'll discuss about the benefits, we'll discuss about the challenges, we'll go through the future trends, neural network, and deep learning. The first topic is natural language processing. And what is natural language processing is? It is a field of artificial intelligence that focuses on interaction between computers and human natural language. So we can see applications of natural language processing in chatbots, translation systems, and voice assistants. And the pipeline of NLP has a resemblance like it is performing text pre-processing, tokenization, stop word removal, streaming and lemmatization, and feature extraction with the help of bag of words and TF-IDF. And this is the neat representation of text processing followed by tokenization and removing the stop word and stemming followed by finally identification of bag of words. It enables the machines to understand, interpret, and process human languages, and it is an interdisciplinary field combining linguistic and machine learning. The main goal of natural language processing is to enable communication between humans and computers. It is widely used in chatbots to stimulate human conversations. It is used in machine translation systems like language translators, Google Assistant, and Siri. NLP pipeline begins with text collection from various sources. Pre-processing includes tokenization, stop word removal, streaming, and lemmatization, as we discussed in the previous slides. The final steps are model training, prediction, where the system learns patterns and make decisions. Now we'll see about the text classification. It is nothing but the process of assigning category labels to text based on the content. This is what we see in newspapers like sports, politics, and technology. And applications include spam identification, sports, business, science based classification. Here we'll study about the sentiment analysis, which is used for determining the sentiment of expressed emotions, which is positive or negative. So the basic model used are few examples like naive Bayes classifiers, logistic regressions, support vector machines are the key examples. Now we will see about the workflow of text classification. The data will be collected and pre-processed and cleaned, and NLP features are extracted. From the extracted NLP features, we will use to identify positives and neutral negatives. And finally, the classification and prediction is obtained. Next comes the image processing and computer vision. Now we need to understand the difference between image processing and computer vision. Computer vision enables computer to understand and interpret visual informations, and it is the combination of machine learning and image processing which performs like seeing and making decisions. And the role of machine learning is providing data used in deep learning, CNN, and powered real-world AI systems. In case of image processing, we have image representation, pixels and resolution, filtering and enhancement, and noise removal. Whereas in image representation, there are different methods like RGB, primary color format, the secondary color format. Likewise, we have different types of image representation, and we need to understand more about the pixels and resolutions and the image pyramids associated with it. And filtering and enhancement is the back-end operation where you will adjust your brightness and contrast of your image and sharpen and blur and enhance the edges for better object detections. Next is image recognition and classification. It is also two different terminologies. Identify what is in the image, find objects and patterns, this is nothing but image recognition. And in classification, category labels are assigned to the entire image. For example, if you are showing a cat is labeled for cat and dog is labeled for dog. And the difference in recognition and classification is recognition can detect multiple objects where classification assigns one label to whole image. And in recognition locates and identifies each, no location info is available in classification. The outputs are labels and positions in recognition. The output is a single label in classification. Next, this is for example, you are giving a data set of cats and dog images, and during the training we are training our model with multiple number of cat and dog images with the appropriate labels. During the time of testing, if a dog photo is shown, your model will able to classify dog correctly. For example, in the example which is shown here this model is able to predict 95% of the data very accurately. Now we'll see about how the computer vision system works. The working is more or less same as that of image processing, but the image processing will be done only in the initial phase of computer vision system. Like the image is captured and pre-processed, and the features from the images are extracted. And these features are nothing but global features or local features, and the extracted features are nothing but the edge and shapes. Now the input is given to the ML model. Here the convolution neural network is addressed. From there we are able to predict the desired output. Next is object detection, identifies and locates multiple objects in an image and draws bounding boxes with labels and confidence. From this we can understand that when an image processing system is becoming intelligent, it leads to computer vision system. In real-world applications, we have self-driving cars, traffic sign detections, CCTV surveillance, and medical scan analysis. More real-time examples like healthcare, retail markets, finances, robotics, social media, and wildlife tracking of animals are performed. And this is the definition, concepts, and techniques and algorithm used, and the examples for them. The computer vision is used in face recognition and autonomous individual identifications. Image processing are used in image pre-processing, filtering, edge detection, noise removal. Image recognition is performed with the help of CNN and classification models, whereas image classification makes use of naive Bayes classifiers, support vector machines, and deep learning. This is another slide which is showing the glimpses or examples of how the image processing and computer vision is carried out. Image recognition, how the cats and dogs are exactly identified. This is an example for it. Now we can classify image processing versus computer vision, recognition versus classification, classification versus object detection. These are the classifiers. You can go through them. Like we are classifying based on definitions, purpose, focus, techniques, outputs, as well as complexity and different types of algorithm involved in recognition and classification. So in face recognition, medical imaging, autonomous vehicles and security systems, the applications of computer vision are highly employed. In face recognition, identifying and verifying the individuals based on facial features is carried out, and facial landmarks are nothing but eyes, nose, mouth, and chin. And face matching compares the face against databases of known faces. In medical imaging, analyzing the medical images for diagnosis and treatment is carried out, and types of important images for the diagnosis like x-rays, CT scans, MRI, and they'll be performing segmentation diagnosis, and they'll identify and label the different types of abnormalities found in the images. In case of security system, which is useful for detecting the intruders and track the movements of intruders or any suspicious behavior of individual inside the area of interest. The real world home security, retail and public safety are all the problems which we have discussed in the earlier cases. In autonomous vehicle, which is very popular now, they are using object detection for detecting lanes, identifying car, pedestrians and traffic signals, and recognizing and marking the parking aids it is used. Vehicle navigate autonomously using computer vision. And machine learning in healthcare. Why machine learning is used in healthcare? For because it is making use of artificial intelligence and data to improve medical care by making predictions and identifying patterns and aiding decisions. The disease prediction using algorithms to identify patterns and predict likelihood of diseases. The real-world uses, early warning of heart attacks or predicting diabetics risk and cancer risk assessments are performed. The medical image analysis to detect abnormalities, detecting tumors in X-rays and MRIs, and detecting fractures and strokes. In drug discovery, it is used to accelerate the discovery of new drugs, virtual screening of chemical compounds, and predicting drug indications. The personalized treatments are performed for creating treatment plans and suggesting best therapies for the individuals and monitoring and adapting treatment over time. The early detection of tumors in X-rays, identifying lung diseases in CT scans, and diagnosing fractures and strokes. So this is where the disease prediction is identified with the help of machine learning. So the process of this begins with an input image followed by image pre-processing, feature extraction and model classification, and then finally detecting the output. This is as shown in the figure. The process begins with collecting medical images such as X-rays, MRI or CT scans. These images serve as the raw data for analysis, and the image pre-processing is performed as a next step. In image pre-processing, they'll perform noise reduction and enhancement, which eliminates distortions in the image, and enhancement improves clarity and contrast. The feature extraction results in identifying the shape of tumors, texture details, and edge information, and classification models make use of like convolutional neural network or support vector machines are employed, and the model learns pattern and classify the images, and the final output will be a tumor detected or not detected. So this is an example for cancer cell detection using machine learning. We can predict or detect the cancer at the earlier stage with the help of X-rays and CT scans. This helps the radiologist to make more accurate and timely diagnosis. And data privacy, sensitive patient data must be protected as per HIPAA regulations. And accuracy and bias, it ensures the model is accurate and fair, and it minimizes the false positives and negatives. In case of ethical concern, responsible AI use should be followed to avoid discrimination and harm, and transparency should be there for explaining how decisions are made. The workflow will see collection of data, followed by pre-processing and cleaning, followed by training ML model, testing and validation of ML model. There we will be performing precision and recall, and finally leading to ethical concern, responsible AI use, avoid discrimination and harm, and transparency in explaining how decisions are made and the final decisions are given. And this is the conclusion of this unit. And we have learnt about the machine learning, which is nothing but training computers to learn from data. And the real world application we have discussed about healthcare, computer vision, self-driving vehicles, and summary of key concepts like machine learning, real world applications, and computer vision are discussed. Now the future scope is continued advancements in artificial intelligence and machine learning. We need to implement the same in smart cities and generative AIs and automation, and new opportunities in smart city implementation, generative AI, and automation are currently in market. So machine learning is shaping the tomorrow's innovators. So this is about the emerging trends and real world impact, and I thank you.